Section 3.3, number 16. The given statement is, there exists a real number u such that for all real numbers v, uv is equal to v. So in part A, we want to simply phrase it all in words. One way is, there is a real number whose product with every real number equals that number. Just as it's important to do everything symbolically, it's also important to be able to express everything or rephrase everything just in words. So we're looking for the negation of this statement. There exists a real number u such that for any real number, or for all real numbers v, uv is equal to v. So we match that with my general form of a statement like this, and I'm looking for the negation of this general statement. There exists an x and d such that for every y and e, p holds. How did I do it in general? Well, I have two steps. Step one, the first version of the negation, is for every x and d, I have the complement of the second portion of this whole statement. And then I match that with my specific statement. So for every real number u, for every x and d, for every real number u, I'm looking for the negation of the second portion, which was for all real numbers v, uv is equal to v. For all real numbers v, uv is equal to v. In general, for all y and e, I have p. So the final version of the negation in general, over here, I rewrite this negation inside the first version, which then becomes, there exists a y and e such that not p. So now I want to rewrite my example as well, which would then be, when I match it, in general there exists a y and e. So for my example, there exists a real number v such that not p, such that they're not equal. uv not equal to v.